This is Lesson 8, 9.4, Day 2, Random Sampling Methods. I'm going to ask that you answer this warm-up question on your own. So I'm going to go right down to the two definitions here, which we have talked about. A population, it consists of all the members or objects about which you want some information. So when we did the little lab activity on how many letters are in your name, the population was our class that was in the room, all the people that were in the room that day. The sample was the 9 other people that you asked, how many letters are in your name? So the sample is a small portion of a population to study and observe. Consider a busy freeway. You wonder what the average speed of the cars on the freeway during peak hours is. All the cars in the population that you want to study. All cars are the population of what you want to study. All cars possible. It may not be possible to track all the cars' speeds. So you're going to track a small sample of cars. It's going to be impossible to figure out, even if you have radar guns and several of them, how fast people are going. So you pick every 5th car or every 10th car or the white cars or the red cars. You pick a sample of them to talk about what is the average speed of any car on a freeway. So the sample has to be representative of the population. As we saw, if you only ask people that live in Alaska, that's not all Americans possible. And it must be an accurate representation of the larger population. To make sure your sample is representative, you can choose a random sample. Random is the key term here. It's sometimes called an unbiased sample. So every member of the population has to have an equal chance of being selected, and they are independent of each other. If you pick a population where members are not randomly selected, then it could be biased. So ways of sampling: simple random sampling, using a sampling frame, for instance. If you have an interview, the sampling frame could be looking up in the phone book, but most people have cell phones now, so they might not be listed in the phone book. You could use this lottery method where you give everybody a ticket, for instance, and then they write their names on it, then you put all the tickets in a bowl and pick a ticket out. So you could give people a number by giving them a ticket number. This could be hard to do if you have a really large population. That's what's called the lottery method. You could use a random number table and assign people a random number table. You could do that. Or you could use a computer that also could spit out some random numbers and assign people a random number. So some more examples of some good, simple random sampling. To study the migratory behavior of loons, biologists randomly tag 64 loons on the Great Lakes. So they just randomly tag them. They're not picking only ones that are on Lake Erie or only ones that are on Lake Huron or only loons that go and stay on the Ontario Beach Park at Lake Ontario. They're using all of the Great Lakes and they're randomly choosing loons. Or to survey some tourists about this historical town, the interviewer could randomly select 150 of the tourists in the town, not just people that have a blue shirt on or something. An equal number of students from grades 6 through 8 attend Martha Brown Middle School. Which group of students would be the best sample to use for a survey that is designed to gather information about the opinions of all the students? So would you ask 125 boys? Would you ask 125 7th graders? Would you ask 60 8th grade boys and 60 7th grade girls? Or would you ask 120 6th, 7th, and 8th grade girls and boys? Well, the most random of all of those, where it's not just boys, it's not just one grade level, and it's not just boys in a grade level or girls in a grade level is to ask all 3 grade levels randomly, a group of about 120, 6th, 7th, and 8th grade girls and boys. That would be the best choice there. Executives at a television station want to know what time 7th grade students typically start watching TV on Saturdays. To get this information, the executives at the television station randomly survey 250 viewers under the age of 20 who watch TV on Saturdays. Will the results of the survey likely be helpful in finding the information that the executives are seeking? Explain your answer. So if you just randomly ask people in this survey, I would say, will this be helpful? No, because they want to know 7th graders, all 7th graders, aren't people under the age of 20. Because you could get an 18-year-old. Well, that's not a 7th grader in the survey. Why don't you, make it a little bit smaller? 250 viewers that are under the age of 20 who watch TV on Saturdays. Well, just because that Saturday somebody's watching TV doesn't mean that they always watch TV as well. All 7th graders aren't under the age of 20. That's first of all a problem. And they're only asking people who are watching it on Saturday. Maybe that specific Saturday you were with your family on a trip and you weren't watching it. So I don't think that that's a valid population there. An automobile company plans to survey 100 people to find out what features they look for in a car that they may want to buy. Do you think they would get the most helpful information at a mall, at a playground, or a bus station? Well, if you're at a playground, maybe you walked there. You could have walked to the playground. A lot of them are neighborhood ones. Not such a bad idea. If you're at a bus station, more than likely you're not driving. So to get to the mall, most people probably drive to the mall. So I think of the 3, choosing the mall, I think the mall would be the best place because you could randomly ask people every 20th person that comes out the door at the mall. The mall has the largest population chance that drives an automobile. You have to be careful. You're not going to want to ask a 10-year-old, for instance, or somebody who's 15 because they don't drive. The mall has the largest population chance of drivers of an automobile. What kind of car? And that's it for today. So very short video today. We'll talk more about sampling again today or tomorrow in class.